Good morning, everybody. How are you? We're getting towards the end of the conference here, and I hope to give you something really, really exciting here. This talk is almost like 3.5 talks in one, and some of the tech that I'm honestly most excited about. I mentioned in the Spinnaker keynote yesterday that one of the advantages of Spinnaker over a traditional pipeline execution engine like Jenkins is that there's this stateful inventory of what production assets and non-production assets you have across your organization. And I alluded to this concept that there were these tools that orbited around a CD system that could take advantage of that inventory to do things that are out of band of actually deploying something. And so today I want to give you a concrete example of just one thing you could do with that asset inventory. So we'll go over the Spinnaker resource model real quickly so you kind of get a conceptual idea of what that looks like. But then the example we're going to focus on here is on vulnerability scanning. So, be thinking, a splashy news headline comes out tomorrow with a security vulnerability in some common Java library that is probably in many places in your organization. How do you quickly identify where you're exposed and kind of rank, the actions that you should take so that you address the most critical things first and the less critical things later. And then the third act will follow up with this project called Rewrite, which allows you to declare or define refactoring rules that you can apply across your code base. And I'll try to tie that in a little bit as well. So we'll just get going, and please raise your hand at any time because we're doing this in kind of 3 acts. It's great to have questions, in context before we switch gears to something else. So feel free to ask questions at any time. So first up, the Spinnaker resource model. The Spinnaker, like I said, is a multi-platform continuous delivery solution. So let's start out here in the infrastructure view. Here we have an application just called demo. And we have a listing of the physical resources for demo across potentially multiple Cloud Foundry foundations. So demo, first of all, is the application demo is a logical construct. It's not, because it spans multiple cloud platforms, no one platform can claim, ownership over what the idea of an application is. It's just something that's spread across many of them. So inside demo, you see we have 2 different Cloud Foundry foundations here. We have a Cloud Foundry Dev and we have a Cloud Foundry Prod. You could easily imagine there being many more of these. You could have, dev, test, staging, prod, multiple prods. You could have, a prod Cloud Foundry account and an AWS prod account. So they wouldn't all have to even be on the same cloud provider. So this is just a representation here of one cloud provider, effectively, that we've called for this purpose CFDev. This concept right here is called a cluster. Demo and demo prod are clusters inside of the application. Cluster 2 is this synthetic idea that Spinnaker is adding. It's adding decoration on top of what the cloud platform knows. If you know anything about Cloud Foundry, you know that if you do like a CF app listing, you would have an app with a number of instances inside of it, but if you had, say, multiple versions of that app running, logically those belong in the Spinnaker parlance into one cluster. So when we get down to what Spinnaker calls a server group, which is this box right here, V003, this server group is the first place where the cloud platforms themselves, where there's actually like a correlated concept. So in Cloud Foundry, if you did a CF apps listing, what you would see is demo dash v003 would be the application name. Down here, the application name for this server group would be demo-prod-v017. And you know, if you're doing a CF apps listing, you would actually see several, several representations of demo on that particular Cloud Foundry foundation. You'd see a demo-prod-v017 and one's v016 and 15 and 14 and so forth. Inside of the server group are individual instances. So, well, first of all, the server group there's information over here related to that server group, such as when it was created, what organization space it belongs into, you know, the root FS of it, build pack, you know, some sizing information about it, its package, etc. This information over here is going to be unique to each cloud provider in Spinnaker. So, you know, AWS, you may have a link to CloudWatch, or you could, so there could be differences between platforms that you know, are presented differently when you look at a server group. Then you get down to the individual instance level, and you know, and there's not much that Cloud Foundry can really tell us about instances other than when it was launched and whether it's up or not. So again, this instance concept here is kind of generalized across cloud platforms. Now the coloring of the instance here indicates whether it's healthy or not, and there's a few different colors. It's blue if it's coming up, it's red if it's down, it's green if it's up. So you could quickly look at a cluster of, say, you know, 4 nodes or 100 nodes or 1,000 nodes and see which ones are up and down at any given period of time. One of Spinnaker's advantages here is that determination as to whether or not something is up or not is based on both the platform's notion of whether the instance is healthy and also the application's notion of whether it's healthy. So if you think about like Spring Boot actuator health, you know, that's going to be aggregated by Spinnaker with whatever Cloud Foundry thinks about the application's health to determine the complete status. So now if I were to roll back, say v017, I was going to take a server group action here and I was going to roll back to v016. What Spinnaker would do is it would restart this v016 cluster, which is still there. It's a CF app with no instances inside of it. It's disabled. It would start it again. It would launch some instances. It would wait until, you know, a sufficient number of instances, according to how you've configured it, a sufficient number of instances are healthy, and then it would flip the route. So right now you see v017 has a load balancer demo-prod.apps.montclair associated with it. Once the new cluster was up and healthy, Spinnaker would flip the route. Spinnaker has an advantage here because, again, it's making the determination as to whether the new cluster is healthy based on the combination of what the platform thinks is healthy, but also what the application thinks is healthy. So think about an application that you may have, you know, there's a lot of different types of applications out there, but suppose you had an application with a large in-memory data store. Oftentimes those applications, like a CQRS event source type application, those applications tend to read from some journal, push everything into memory, and then they're ready. You can imagine creating a Spring Boot application where you create a custom health indicator to say, when I'm done reading the event log, then consider me healthy. If you just looked at platform health, once the application starts, but the event log is still being read, you know, a platform-based blue-green would go ahead and flip the route. But the new cluster isn't ready yet. So that aggregate view of platform and application health is real key. Let's see. So this is kind of the infrastructure view. And then we mentioned there's also pipelines, and we're not going to get too deep into this today, but just know that for a particular application, there can be pipelines that are kind of arbitrarily complex. In this case, this one's really simple. There's just, it's manually triggered. There's a deploy stage. You can add additional stages. You can add manual judgment phases. You know, you can resize and destroy server groups here. Lots of different kinds of things you can do to kind of create a complex pipeline. I think we've got an example of one we showed briefly yesterday. I believe it's this one, where you can see a quite complicated pipeline where we've got something like prepare the test environment, that is, create a database resource or something like that in a test environment, deploy the application to test, run tests on the test environment, deploy the latest production version, like basically go snag the latest production version and bring it back to the test environment to ensure that your database changes haven't broken the latest version, so that you can be sure that you could roll back to the latest production version if the new version of code is wrong. Wait for the staging environment. So there's a, it can be as complicated as you want it to be, basically, is all there is to learn about this. So are there any questions or thoughts about the Spinnaker resource model before we move on to the next phase? Yes, sir. Yeah, the question was, what would it look like for Kubernetes? And really, the only difference is the logo here. I mean, that's literally it. You just see a different logo. So from this presentation, it looks exactly the same. Yeah, so the question was, is in Kubernetes, is this a pod? I think a pod is the server group level, and then the individual containers, is that right? Am I getting this backwards?
So in Kubernetes, it's a deployment of a replica set, and a pod is the individual instance.
There you go. Thank you, Olga. So the replica set is the server group. The pod is the individual instance for Kubernetes. For Amazon EC2, this is, of course, there's an instance is the instance, and AWS server group, or ASG, would be the server group level. So it depends on the cloud provider, but each cloud provider has this mapping to this resource model. It's surprisingly durable, this model. We called this a multi-cloud delivery platform. It's also, for lack of a better word, a multi-abstraction delivery platform. So, if you're used to deploying things in kind of a VM-based way, you're going to get this presentation. If you're used to deploying things in a container-based way, you're going to get this presentation. And this presentation also works for serverless type things. Now, the instances in a serverless world are going to cycle more. They're going to come up and down more frequently. But the basic presentation doesn't change. Yes, sir? I'm sorry? Yeah, the question is, can it be done in a declarative form? So, in other words, the pipelines can be done in a declarative form, or? Yeah, Spinnaker does have a declarative continuous delivery model. I think that's being iterated on a little bit right now. Has anybody heard of Spock, the groovy testing framework? Pretty kind of. So Rob Fletcher, the main author of Spock, that's his full-time job right now, is working on declarative continuous delivery for Spinnaker. I expect he'll continue to evolve it into something really awesome. Yes, sir? It's a combination of both. So you set it up however you set it up on the application. For boot, of course, that's /actuator/health. That's going to be the typical thing. When you go to create your deployment stage configuration in your pipeline, you can indicate this is the health endpoint I want you to look at. And so it could be anything. If it's some other esoteric, languages framework that's got a different endpoint, then point it at that. And all Spinnaker is really looking for is just an HTTP 200 or not, on that health endpoint. Yes, sir.
Is there a way to do like templates or something, so like in the proper organization, like everybody's pipeline start off from a base that's the same everywhere?
Yeah, the question is it possible to do templates in order to create a common experience for pipelines across your organization? And this is sort of connected to declarative continuous delivery. There is a concept called managed pipeline templates that allows you to define a template. They can be checked into source control or something like that. And these templates can be composed or inherited from, or there's points of extensibility in them. That's one real advantage too I see, is that we talk to a lot of organizations where there's this kind of internal war on do ops control the pipeline, or do the developers control the pipeline? and and somebody's going to win. And they both have a point, right? Like it makes sense for there to be some organization-wide compliance check or auditing check or something of that sort. However, applications are different, so there needs to be some variation as well. And so I like to come in and say, wait, this isn't a zero-sum game. You can have both with something like managed pipeline templates. Yes, sir. The question is Spinnaker going to replace Concourse? And let's be specific about that. I should have been specific about that already. The answer is no. We view Concourse as a continuous integration product, much like Jenkins or Travis CI or Circle CI or any other continuous integration system. The start of a pipeline is always this configuration. And so there's these automated triggers that can trigger the pipeline. Of course, you don't have to define any triggers. You can manually trigger them as well. But there's different trigger types, and one we're demonstrating here is Jenkins. We imagine the end of continuous integration always being the deployable artifact, whatever that is. For Cloud Foundry, that would be a jar for Spring Boot. If you're deploying Docker, it would be a container image. And then, so if you're, say, like deploying a jar to EC2, it'd still be a jar. And there would be a bake stage in your pipeline where it gets turned into an Amazon machine image, and then it's deployed after that. But the key point is wherever that artifact ends, where it winds up in an artifact repository, should be the end of continuous integration. And then your delivery pipeline picks up. Now, you may have some existing investment, some custom stage, like testing type thing that you're doing with that artifact once it's in the test environment. And for that, we would say, leverage your existing investment. You can add a stage here that just runs a Jenkins job. So, once the CD process starts, you could still farm back out to some other execution environment to perform some sort of test. But, in the meantime, separate these responsibilities. Yes, sir. Yeah, how easy is it to work with custom webhooks behind a firewall? Sure. I don't know. I mean, I think you'd have to, the typical model we try to promote is that you try to get to one Spinnaker per org. Perhaps sometimes two if you want to separate SOCs and non-SOCs or something like that. But and wherever the Spinnaker resides, it typically resides on some sort of tools cluster or something that has quite a bit of access because it's going and querying cloud platforms across your organization. So I think it would be up to you to make that connection possible for the trigger to happen. But it's hard to answer generally, I think. Yes, sir. Mm-hmm. Mm-hmm. Yeah, I mean, right now the stage is Jenkins job, not Jenkins pipeline. I think we'd be interested in that use case. I don't know what the community would accept there, but I think the question, if I understood it correctly, was whether Spinnaker could execute a Jenkins pipeline. Yeah, so in other words, what's the difference between Jenkins and Spinnaker pipelines? I look at it from the responsibility segregation. I can imagine a Jenkins pipeline being used to do whatever work needs to be done up to and including the production of an artifact, and then continuous delivery picks up from there. Mm-hmm. Yeah, so I understand here that Jenkins is pitching itself as a CD solution as well. If you're sold on that, great. I view their CD solution as as not as strong because it isn't paired with the asset inventory, the stateful notion of what's where in production, and that really is it's really important when you think about say rollback testing. I showed you something in here where you're deploying code up to test, you're doing some tests there, then you go snag the latest production version and drag it back to the test environment. To even do that, you need to have a notion of what is in production in the first place. And any process that if you try to formalize what's in production by say like tagging your repo with what's in production, so like it winds up falling apart because if I take some manual action like rollback on the side, I have to tie that to that same process. So. And I think the illustration in a little bit here where we talk about refactoring and vulnerability scanning is going to demonstrate something as well that's different. So, yes, sir. The question is, does Spinnaker do anything for the database part? I think how you how you upgrade your database would be encapsulated in some sort of stage. You see here in this case, we've got this prepare for test environment where we're executing some sort of script or doing something to do that. It's Spinnaker has either the go execute this thing on some other CI system type stage, and it also has a script stage where you can do whatever you want. You just plop it in the stage configuration and do whatever you want. So I think that's the typical place for that. Yes, sir.
You said when it's hosted in like a tools cluster, would it be inside would it be a PCF or is it a file?
Yeah.
Or a series of VMs like Concourse?
Yeah, the question is, I mentioned a tools cluster, and is our intention to deploy that inside a PCF or a tile or something of that sort? Our current plan, because we have the PKS product now, and because Google has worked quite a bit on automation around deploying Spinnaker to Kubernetes, is that we would say there's going to be a PKS tools cluster, and Spinnaker will be installed there. And that PKS tools cluster, or the Spinnaker inside of that tools cluster, will be pointed at all of your Cloud Foundry foundations, and also that cluster, and any other PKS cluster you have, and any AWS account you have, and so forth. There's, and this is early, but there's other things we imagine for that tools cluster. We're working right now on on metrics for the platform. We're looking at operationalizing Prometheus for the platform, and we imagine having multiple foundation Prometheus federation living inside of that tools cluster as well. So I think that's going to be the deployment strategy going forward, is to kind of leverage a side Kubernetes cluster to do the installation. Any other questions about this? These are all good. Yes. Yeah, the question is, does Spinnaker allow you to model a potentially multi-application group? And and the answer is yes, but there's a stage called the deploy manifest stage that can take like a multi-application manifest and rip it apart and invoke other pipelines to do the deployment or rollback or whatever you're trying to do. In that sense, if you had like a 3-app multi group of things, what you would wind up seeing in Spinnaker is just an application name that whatever that you call that logical grouping would be, and the pipeline would be a deploy manifest stage, and it would invoke pipelines for the individual 3 services. We try to I think that's where a lot of people are at right now, and so it's supported, but we're trying to discourage that because when you think about like deploying a set of 3 applications together, there's no way to do it with 0 downtime. There's no way to roll back with 0 downtime. There's no way to do automated canary analysis, so you lose much of the benefit of like best practices concerning deployment strategies when you do that. Because there's just no way to orchestrate the, I'm standing up a new thing, I'm waiting for it to be held, now we're going to move all the routes at the same time. There would be a gap no matter what you do there. So we try to think like, when you change your APIs, make backwards compatible changes initially, deprecate, remove later kind of thing, and encourage those patterns. We had a talk yesterday, and you can watch the video on, Marston was up here talking about contract testing. Many times folks stand up multiple applications in an environment just to test the integration between them. And much of that can be accomplished by other means, through contract testing that's done at the build without having to stand up multiple applications at the same time. So, yes, sir.
Can we roll back multiple stages of one stage change? How can I roll back all those?
Yeah. The question is, can I roll back multiple stages? And the rollback in this case is a rollback of infrastructure and not of stages. So if we look at demo over here again, this cluster was created with what we call the red-black strategy. So rather than, when you release a new version of your application, rather than just destroying the old thing and creating a new thing, we disable the old thing, or we create the new thing, wait till it's healthy, move the route, disable the old thing. So this is the point at which you can roll back. You can do a server group action to roll back this, or resize or disable or destroy or those kind of things. So, yes, sir. Yeah, the question is it always a manual click? And the answer is no, there is a rollback stage. So if you had a pipeline, you could perform some tests and then perform a rollback as a stage if something fails or something of that sort. The other server group actions are as well, resize, disable, destroy, those are all stages as well as server group actions. The other things like terminate instance, oftentimes this one I've done manually. So, and just in my experience with Spinnaker over the years at Netflix, the common pattern I found was I had, good alerts on metrics coming out of my application. I'd be alerted to some problem. Usually it's a resource problem, like I'm starting to run out of memory on this instance. But because there's a cluster, not all instances run out of memory at the same time. The traffic is asymmetric to them. And so you'll see in that alert, you'll see like it's actually this instance right now that's under duress. And I can come over here to Spinnaker and I can just kill that instance and let the autoscaler bring another one up. And that just buys me time, basically, while I'm trying to figure out the root cause. I've got this great like interplay between my metric system and Spinnaker where, I'm taking the alert over here information, and I'm going over and I'm taking some action on the server group or an individual instance. Yeah. I think there was a question back there. Yes, sir.
Yeah, you talked about the inventory, but then we're also talking about containers and they're ephemeral.
Mm-hmm.
If you do like an upgrade in the background and the containers get shuffled,
Yep.
how do they show back up here?
Yeah. So the question is like, we're talking about an inventory, but sometimes the platform is actually repaving or there's some ephemerality to the actual infrastructure. And the answer is the Spinnaker itself is polling periodically. It's always watching the cloud providers for changes. And in fact, and maybe to make this explicit, this infrastructure view here is not just infrastructure that Spinnaker has deployed. When you install Spinnaker and you point it at an existing AWS account or Cloud Foundry account or Kubernetes account, it's going to go inventory everything. So you'll see right away, health indicators on all your resources across your assets. There just won't be any pipelines yet. So it's kind of nice. Like even if you do have something like Jenkins going on right now, you can just kind of stand this up on the side. You can take advantage of the inventory side and while you consider what to do with pipelines. If you want to do something different for pipelines, great. But yes, sir. That's okay. Yeah.
So if you stood Spinnaker up and you had apps that were already going out there, it seems like there's some convention as far as like the names of the apps,
Mm-hmm.
Cloud Foundry, like
Yep.
017.
Yep.
I think there's a migration path to go from my app that doesn't have that convention to Spinnaker.
Yeah, the question, and this is a great question. Thank you for asking that. He's saying it appears that there's some sort of naming convention, like V017 that Spinnaker, has, and it depends somewhat on the cloud provider. The Cloud Foundry implementation has to use a naming convention called Frigga, which doesn't mean anything, just it's a naming convention. What happens when you point Spinnaker at an existing environment? If that application doesn't follow the naming convention, it's very like, it kind of backs off. And so what you would see for some like foo that exists right now is you just see V000, because it just can't infer anything about it. This version, by the way, is not tied to application version or anything. It's really just a sequence number. And it's used to sequence rollbacks and to give you some information anyway. The migration kind of works well because, like for example, Cloud Foundry doesn't have a multi-application blue-green like naming strategy right now. So what you get by default is exactly what Cloud Foundry supports out of the box, which is just applications with different names. And then as you start to use Spinnaker to deploy things, then that naming gets just better over time is all. Yeah. Yes, sir.
Can you do granular security into it so that you can have like dev groups being part of it,
Yeah.
parts of this part of it, and like
Yes. And the question was about security and like role-based authentication here. I'll provide a high-level answer, and then Olga knows great details about the internals of that, and you can talk to her afterwards. But Spinnaker basically has two different security concerns. There's you have to provide credentials to Spinnaker itself to be able to query the application inventory so it can present this view to you. And then there's the user authentication as well. So user roles can be scoped down to applications or accounts and so forth, so that only certain users could deploy to CFDev or they can only view this set of apps. So there's kind of like security on both sides.
Can you get SAML into it?
Yes. Mm-hmm. Yes, ma'am.
Hold on, the last two questions.
Uh-huh.
When you mentioned about the V017 or whatever the
Mm-hmm.
testing that is going on, is there a way to tie it back to the artifact when it's getting moved from artifact to your Micrometer?
Yeah. I don't have it in this view, but because I don't have that feature enabled. But there's a couple ways. Sorry, the question was: is there a way to tie back that V017 to like the build, like the Jenkins build, or to the Artifactory artifact, or something of that sort? When you create, when you have a trigger like a Jenkins trigger that creates these assets, the trigger is triggered with a build number from Jenkins, and that would show up here as a link. Like you would see build whatever, and that link would take you back to Jenkins. But there's also entity tagging in Spinnaker where you can insert arbitrary just tags, and they show up as a little flag right here next to your infrastructure. And it can contain anything, links, markdown, basically, whatever you want in it. And so as part of your deployment pipeline, you could basically plop tags on these things. And then there's a separate concept called alerts, where you can place, and it just shows up as a different icon, like a little warning triangle, again, with arbitrary text in it. Netflix uses the alert mechanism. They have a central team that is looking for bad practices, basically, and they just flag server groups with, information about the context, like, here's the problem we see, here's some resources about what we want you to do to fix this, and so forth. And so, developers are commonly looking at their infrastructure to see those things. And, so it's kind of surfaces it for them in a way they can do something about it.
One more question on the
Sure.
on that. So when you do the deployment, I see, is it like, can we provide custom commands to it? Like, it's not a straight CF push, I want my domain to so and so or something like that. And would that take into effect when you do the back, like the redeploy part of it, when you're going to the previous version? Would you take the same parameters that it has used during the deployment of that particular?
Yeah. So the question is like how much control do you have over the deployment options? Is this a simple CF push, or is there more control? And the answer is, the deployment stage configuration for Cloud Foundry specifically can take either a manifest with all of its variety of options in it, or you can define it, in the UI wizard. Basically anything, most of the things you can do with the manifest, you can just click through in the UI as well. So it should have the full, whatever options you can do with the CF manifest you can do here. When you roll back, in this case, like we have a red-black deployment, and we've defined this red-black deployment strategy to preserve the last 4 versions of the application. It could be 2 versions or 1 version or 10 or whatever. This app still exists in CF. It's just disabled. It's stopped. And so in essence, CF has already preserved whatever configuration this thing was deployed with. When you roll back to it, it's just a simple matter of starting it again, waiting for it to be healthy, and then flipping routes. Yes, sir. Yeah, the question is, can you roll back from 17 to, say, 15? And yes, absolutely. When you click the rollback action, you select which version you want to go back to. And that's nice, right? That's different than, it's not just like a simple, like a predefined script. You could be jumping back 3 versions. Yes, sir.
Is the rollback, is this really like for like when you go from V17 to V15, is it just like rolling back the CS application, or is there like an inversion of the pipeline? Like if part of your pipeline of that, this probably wouldn't be a good idea. If you had done a database migration, and you had a way to roll back that migration, would it be executing the whole pipeline to go back?
Yeah. So rollbacks in this sense are just rolling back the CF app. It's just going back to a prior version. If you could define a separate pipeline that defines a rollback action that does other things, and that rollback is a stage. The rollback in the server group sense is a stage, and so you could preface that with database whatever you're doing, and then execute the rollback stage. So you can get as complicated as you want. I'm saying that, and if Marcin was here, he'd probably slap me on the backside of the head because he gets really excited about like not making database changes always being, forwards compatible, I guess, or backwards compatible. But yeah, it happens. So, all right. Well, I think we'll move on to the next phase, and there's definitely be an opportunity for more questions later if you'd like. We'll try to just run through this really fast. Context again, we think CI and CD have distinct orbits. If they didn't, if it was just like different tasks, then something like Jenkins pipelines would be perfectly sufficient. But it's not just the act of deploying, it's the stuff that happens afterwards. We've seen some of that with rollbacks. We're going to focus on vulnerability scanning for a moment. There's 2 somewhat related approaches here we could take just as like a simple, quick way to do this. When a vulnerability comes out on a common Java library, you could just say, where am I using this dependency? But I think what we found, I think there was a Commons Lang vulnerability a few years ago, and that really flipped the thinking inside of Netflix because the security team wanted to say, everybody stop using Commons Lang. I was like, well, that's great. That affects absolutely everything. And it's just not actionable. There's just no way you could take quick action on that kind of thing. And I think that's true of just about everything that comes out. You know, there was a Jackson vulnerability a year or two ago. Jackson's used everywhere. You know, it's just not actionable. At some point, you know, the library author is going to patch it, and yeah, you could upgrade all your versions, but you know, there's always that intervening time where it's difficult. So, you know, when these vulnerabilities come out, they're not, the whole library isn't vulnerable typically, right? It's just some dark corner of it. And not uncommonly, it's an infrequently used dark corner of it, which is why we haven't discovered this before. So one approach would be to generate basically a binary call graph for the whole application, and then just determine whether there's any call paths that lead down to the vulnerable method. This approach is imperfect, of course, because you can have, you know, you can have reflection and things going on, but if you itemize the paths that lead from the vulnerable method to whatever their roots are and just look at the list, it's typically pretty obvious what's possible to happen and what isn't. So because we're short on time, I'll just kind of just look at this briefly. There's a GitHub repository at the beginning of the slides that has all of this code, so you can rip it apart and look at it in more detail. But using ASM, it doesn't actually take quite a lot of code to rip apart a Spring Boot jar, which of course has all of its dependencies inside of it, and then build a call graph, and then just walk the call graph backwards to determine what's possible to get hit. So it's just a simple ASM class visitor with a method visitor inside of it. And then the only other task really is to look at a jar file, iterate over its entries, look for class files. You know, if it's a jar file, recurse down one level, and that's it. You know, so you could build up a simple call graph that way. When we run this, we see, we'll focus on this. So I should have mentioned, security companies are increasingly doing this. They're not only giving you information about the CVE, but they're also being specific about what method is vulnerable. And this is one of like the key value propositions I think that these security companies provide. You know, there's some context around what the problem is, but like you go do the research on what the method is and tell me, because you know, it applies to all of us, right? So SNCC is one such example. SourceClear does this. There's others, but in this case, we're looking at a zip slip vulnerability in ZTZip, not a super common jar, and SNCC has identified that there's a vulnerable method process in a class unpacker in ziputil.java. So I've created a web application that uses that jar to unzip a zip file. And when I run the little vulnerability scanner on it, sure enough, I find that ziputil.unpack is called by my controller. And you know, there's some other things here. So you can call these false positives, but ziputil.unpack is also called by another ziputil.unpack. Obviously, this isn't a call chain that could be you know, invoked from a user interaction, but again, there's never too many of them. You can kind of look at it quickly and determine. You can kind of group by call chain and determine quickly what you've got. So when I think about how Spinnaker comes into this, you know, we've got a lot of source. Many of us have a lot of source repositories. Like there's a lot of dead code. There's more than exists somewhere in production. Certainly more than exists in the critical path. So if we can, and this is kind of proprietary for each organization, but if we can take our source repositories, understand what the binary dependency tree is, and then look at something like Spinnaker if we basically walk backwards, if we start from, I know that this method level vulnerabilities exists, I'm going to iterate over all of the production assets that Spinnaker is telling me about, get the binaries that are in those production assets, run the scanner, and then just list, you know, what's vulnerable. We can get a much better idea. And because Spinnaker has this, you have different accounts. You have CF prod, you have CF dev, you have different orgs and spaces in there as well. You can sort of group by severity, right? Like deal with the production things first, then deal with the development things after that. Several organizations have some sort of ownership service as well that ties ownership to either production assets or to source repositories. Twitter has something called Service, which does that. Netflix had Krieger, which did that. If you tie these like 3 or 4 sources of information together, you can really get at something pretty quickly. Another approach would be to define refactoring rules that can be ran across your organization once you know about something. So for this, there's a tool out there called Rewrite. We call it a distributed code search and refactoring tool for Java. We'll introduce this quickly. Suppose we had this simple class here, and for now we'll focus, rather than on vulnerabilities, we'll talk about Guava problems because we're all familiar with that. Suppose we had this simple class. It's using a deprecated method, first non-null. What Rewrite can do is it can read Java source and parse it into an abstract syntax tree that has special information about it. And the Rewrite abstract syntax tree contains these like higher order functions to search the code effectively. So in this case, we're just compiling this one class, and we see the first class's name is A. Nothing special there. The Rewrite AST covers the whole Java language. So something like this, if you're not familiar with ASTs, the source on the right here would get broken down into some tree that looks like this. Rewrite's AST is unique amongst, there's IntelliJ has an abstract syntax tree, Eclipse has an abstract syntax tree, the Oracle compiler internally has an abstract syntax tree. Rewrite's is special because it's serializable. It's acyclic and it's type attributed. So serializable is important because we can take a body of source code, we can parse it into the AST, and then we can write out that AST in a serialized form somewhere in a database or something else so that we can quickly act on that. We can deserialize it and act on that without having to go back and parse it again. Most ASTs are non-serializable for a variety of different reasons, so you'd have to do the act of parsing the code every time you want to change your search criteria. Rewrite's AST is acyclic, which is, of course, the dependency of it being serializable, and it's also type attributed. So it's not just looking at the structure of code like this, but it knows that objects refers specifically to this, Google Common Base objects, not to some other objects, which is important a little bit as well. Rewrite's AST also preserves formatting, which is interesting. We're going to, in a minute here, actually generate automated fixes for Guava. And if we didn't preserve the formatting, if we just sucked in the AST, made some changes, and then spit it back out, and changed all the indentation in the source files, that would make developers really angry, right? They like their little, they like their pretty little indentations and special new lines and so forth. So, in this case, we've taken and parsed this file right here. We've gotten the first method, actually, just the first method and the first statement inside of that method, and then we've printed out just that statement, trimming the indentation, and you can see how it preserves the weird esoteric style this developer decided to use for arrays.as list. So there's higher order functions like the ability to find method calls. Like you can use this kind of expression to say, I want to find as list with the receiver type of arrays with any number of parameters. I want to find fields. You can find types, type references, imports. we can suppose we had these two deprecated Guava methods. We have objects.firstNonNull, which Guava deprecated at some point, and for no explicable reason, they moved it to a class called moreObjects. Same signature and everything, they just moved it to a different type. They deprecated it in one version, the next version they removed it. So if you've got an organization, you're using Guava across your organization, and you're not all aligned on the same Guava version, you're going to break somebody. And more executors, .same thread executor, they renamed the method, helpfully. So with rewrite, we can parse a source file, and we can take these high-level refactoring operations. You can change method targets to something else. In this case, we're saying if you find objects.firstNonNull, change it to the moreObjects receiver type instead. And if you find moreExecutors.same thread executor, change it to direct executor instead. Now, when you execute these operations, rewrite knows how to say, like, if I need an import on moreObjects, I'm going to add it. If I see that objects now no longer has any references, I'll remove that import. So in addition to changing the actual call site, it's going to do whatever other changes are necessary to accomplish that. So the fixed code can be just written out of refactor and used to overwrite the original code. And so refactor is the AST right here. We called fix on it. And then you can just write print. And it just emits the string with your source code fixed. In this case, you'll see it's rewritten the import statement up here to moreObjects. It's removed the old import statement on objects. It's renamed this call site, and it's renamed this method here. Separately, if we want to, rather than re-emitting the source, we can emit a diff from rewrite, so we can do whatever refactoring operations we want, and rather than calling rather than calling print, we can call diff. And all diff does is it just generates a get style patch. So you can use this really quickly to just generate pull requests or whatever else you want to do. We have in the source repository that's attached to this presentation, we have all the rules for Guava transformation according to their release notes. So this is just something you could take off the shelf and run. We'll skip that for now. We're running close to time. So we're going to do something really cool here. What I would typically suggest is an organization come up with a way to iterate over their source repositories and parse these things, parse source files and then emit it with some process. But since I don't have a large body of code myself, we're just going to go ahead and fix Guava issues across all of GitHub. And that should be a larger body of code than you have in your organization. So so you can see that it can work. You will use BigQuery, Google BigQuery, to find all the Guava code in GitHub. Google has a copy they get from GitHub every day of all the source control in GitHub, and they make it available as a public data set with BigQuery. So we'll start out by just selecting all the Java files in GitHub with BigQuery. And then we'll cut it down, or we'll basically move it to a subset data set here. If you're using all the steps to reproduce this experiment are in the repository. If you're using the GCP free tier, executing this query will eat into your free tier a little bit. It cost me $6 to move all of the Java files on GitHub over into my own custom data set. And then we can just do a quick dirty thing to cut down all those source files to just those that refer to Guava packages by just doing a simple containment search. So what we've got now after this is 2.6 million Java source files referring to Guava, spanning 47,000 GitHub repositories. So now we're going to stand up, we could stand up something like, this is a lot of source files to parse, right? 2.6 million source files to parse. So, we could, we're not going to be able to just run this on one machine. We're going to have to do this some other place. So for the repo contains instructions for this. We could stand up a Spark Zeppelin cluster on Google Cloud Dataproc. The repo also contains a special Atlas collector application you can run so that the worker nodes that are going to do the work can report timings on how long it's taking to parse individual source files, so we get a notion of how fast things are running. We can skip that. That's the timing logic. So in our Spark query, we already have a subset of all of GitHub, the Java files that contain some reference to Guava. So what we could do is select that table into the Spark job, just map over every row, run that rewrite parsing that you've seen already, new Oracle JDK parser.parse source file, and then export the results, the type attributed AST. I said it was serializable before, just export that back to BigQuery. So we do this with just a couple nodes initially, and measure how fast we can parse things. And what we find is that rewrite can parse Java source files on average about 1/10 of a second per source file. And you do a little math and say, if we add about like 120 VMs to this cluster, then we could accomplish about 3,200 files per second. And we could be done with all of GitHub in about 13 minutes, which isn't too long to wait. You can see now why I didn't want to run this on my local machine. And to prove that this works, after scaling up the cluster with a bunch of cheap VMs, we can indeed see that we're parsing at about exactly what we expected with the math, 3.2K source files per second. So the refactoring operation has been ran, they've all been parsed rather, and we can quickly check how many source files made it through this parsing process. Some were just so badly formed that the parser just didn't even know what to do with them. We can determine that about 2.5 million of the 2.6 million files were parsable. It's something we can do something about, so that's pretty good. That's 96% of Java files containing Guava references. And we found a healthy number of issues. When we ran this rewrite rule, we found that 4,800 projects had problems that are going to break somebody at some point. It's about 10% of all projects referring to Guava have uses of deprecated APIs. The effect was close to 43,000 source files and 70,000 lines of code could be changed just like that. So what's cool, again, the demonstration here is that using a tool like Rewrite or using what we were talking about with binary call graph searching, you could declare some sort of change you want to make in your organization and then iterate over all your production assets and affect that change very quickly. At Netflix, we used this. We had an old logging framework that preceded SLF4J. It was called Blitz4J, and they deprecated it, but nobody, there was 400,000 references to this thing remaining, and nobody would ever do anything about it. So we used this to quickly just eliminate that old API. We used it for Guava changes, for vulnerable method changes, and things like that. And what was useful is when a team, like a core team, wanted to make an API change, say, they didn't know how many people they were going to affect. So they could use the whole body of parsed abstract syntax trees and we'll do a little find method rewrite a call and just search the whole organization and then group by team. And if they found that, well, this change is only going to affect 2 teams, I'm just going to go talk to them. I'm just going to go literally walk over to their desk and talk to them. But if it's going to affect 200 teams, well, then I'm going to do something different. I'm probably going to deprecate it for now. I'm going to, build automated PRs or something like that. So you can take different kinds of action depending on what's happened. So that's a whirlwind. Any questions about this process? Yes, sir.
Can you give this to Google so they don't do this stuff in the future? They can
I don't think they would listen, to be honest with you. Yeah. Interesting though, right? Yeah. Yeah. Any other thoughts on this? I know that was quick. All right. Well, I'll be here afterwards. Thanks for listening in, and enjoy the rest of your conference. What little there is.